Okay, so 1.2, we're going to be solving two-step equations. I believe in the 1.1 practice, you had a few of those as well. So you kind of have been introduced already. So there are just a few things I'm going to tidy up with that, and then we're going to hit some proportions, as well as some word problems, just kind of getting you into the idea of connecting and building. So here we go. With the first one, we're going to combine like terms if necessary, isolate the variable, and then use add or subtract just first, and then multiply or divide to isolate the variable. The first one is concept one, solving two-step equations. So let's line down the middle, and we're really going to look at the side of the variable. And is there any addition, subtraction? If so, we're going to undo it. So we're going to inverse operate the minus 9. And we get 5x is equal to 15. And then we're going to divide by 5 to get x equals 3. The next one, b, it's just like it, so try it on your own and then push play and you can listen to my explanation. So I will pretty much do the left-hand column and I'll be asking you to try the right on your own and then check your work. Line down the middle. And then y is equal to 5. Oh, that's ugly 5, but it's 5. The next one has a fraction in it, but that's okay. It's just division. So we're going to undo the minus 7 because it's over here with a z. So plus 7. So I get 6 is equal to z over 3. Multiply by 3 to get rid of that division by 3. And z is equal to 18. Try d on your own. So pause me and try d. Right? Add 8. Now 15 is equal to 5 over 6x. So now I need to multiply by the reciprocal to get rid of that. So 6 over 5 multiplied by 6 over 5. This is like over 1. And we're going to reduce and reduce. So I get x is equal to, and reduce this. 5 goes into 15 3 times. 8 times, or 6 times 3 is 18. The next one, concept 2, solving two-step equations by combining like terms. So the first thing I want you to do is combine like terms if there are any first. So on this one, line down the middle. I would say like 4 watches or 4 watermelons plus 2 watermelons would give me 6 watermelon equals 24. And then now I can have them combined. So I can divide by, ooh, undo. Oh, ugly. Ah, start that again. I'm going to go 6w is equal to 24. Now let's divide by 6 on both sides. So w is equal to 4. Try this next one on your own, please. So pause and try it. So 8t take away 3t, or 8 teeter-totters take away 3 teeter-totters gives me 5 teeter-totters equals 35. Divide by 5, t is equal to 7. Okay, the next one, it's on the right-hand side, which is just fine. So 5d minus 9d gives me negative 4d is equal to 16 negative. And then divide by negative 4. So d is equal to negative negative is a positive. 16 divided by 4 is 4. The next one, try it on your own. So pause me and try it on your own, please. Okay, if I've got -5 plus 13, and those are both k's, so -5 kites, I have order for 5 kites, and I have 13 in stock, I would fill the order and I'd still have 8 of them left. And then now we have to divide by 8 boxes. So at -4 is equal to k. This next example, it has proportions. So we're going to have to do some solving proportions, which we know is cross products are equivalent. Cross products are equal. So that's the first step thing that we're going to do. And with that, I'm going to do the 2 times the x, so that will give me 2x is equal to, and then 3 times, and it's this quantity because there are 2 terms here. So it's going to be 3 times x minus 6. The next thing we're going to do is distributive property. So distribute. So distribute the 3, and I have 2x is equal to 3x minus 18. Line down the middle. Now this one is where we're starting in with variables on both sides. I need you to move all your variables to one side. So if I have a 2x over here by itself, but I have a 3x and a -18, these guys are already alone. So let's just move this 3x to the left-hand side. So to move it across an equal sign, we do the opposite sign, the opposite operation. In this case, it's adding and subtracting here, and the 3x, I want the whole thing, so I'm going to go minus 3x. So now I end up with my equal sign here. This is -1x equals -18. I don't want to solve for negative x, I want positive x. So I need to get rid of the -1, which is multiplied by x. So divide by -1. And now I get x is equal to positive 18. F. Try that one on your own and then push pause and then try it on your own. Okay, going cross products are equivalent. I'm going to say 4 times the m is equal to 5 times the m minus 6. Make sure that's in parentheses. The 4m doesn't necessarily have to be. So I get 4m is equal to distributive property here, 5m minus 30. Make sure you multiply that second item as well. So after I did that, I didn't put my notes over here. The next thing we did is move variables to one side. So line down the middle. I'm going to move this 5m by going opposite operation, so minus 5m. Again, I get a -1m equals -30. I'm going to need to divide by -1. So I end up with m is equal to positive 30. Concept 3, we're going to find the input and the output of a function. So when I'm talking about input and output, hopefully you realize it's x and y. X is my input, y is my output. So anytime I see the word input, I want an x. Anytime I see an output, I want the y. So output of, so that's going to be the y, of a function is means equals 5 more than -2 times the input. Input means x. So find the input, find the x, when the output, y, equals 11. So I'm telling you that y is 11. I want to know what x is. So let's write our equation. First of all, we know that y is the output. Oops. So I'm going to say y, maybe, y is equal to the input, right? So 5 more than negative 2 times the x. So 5 more means I'm going to add 5 to negative 2 times x, so negative 2x. But then my last one says when the output is 11. So I now know that y is 11. So 11 equals negative 2x plus 5. And I need you to solve that. So we're going to put the line down the middle, take away 5, 6 equals negative 2x, and divide by negative 2. So negative 3 is equal to x. If we're doing the full less method, I would label my variable input equals x. Let's label my equation. My equation is over here, and then I solved it. And then my statement would be the input is negative 3. So B, the output of a function, output is your y, of a function is equals 4 less than 4 times the input x. Find the input when the output y equals 3. So if you want to, we can say the output is 3. So when 3 equals, because y is 3 is 4 less than, so take away 4 from 4 times the input, so 4x. So L labeling x equals input. My equation is right here. Solve it. Add 4. So we'll get 7 equals 4x. Divide by 4. And I end up with 1.75 is equal to x. So that would be my solve. And my statement, the input is 1.75. All right. The next one, example 5, we're going to rent a booth at the fairgrounds, $42 a day plus one-time equipment fee of $85. Find the number of days that Miss Crafty rented the booth that she's paid a total of $337. So, well, Miss Crafty, here we go. To rent the booth at the fairground, it costs this much per day plus a one-time fee of $85. We don't know what per day, so I think it's going to ask me if I find the number of days. So I'm finding the number of days. Per day, we don't know how many days. So I'm going to let x equal number of days. That's labeling. When I look at this, I want my total to equal her cost per day times the number of days plus the base fee. So if we can put in her information here, we have the total. Total is $337. The cost per day is $42. Number of days, we're going to say, number of days is X plus a base fee or a one-time fee of $85. So there's my equation. And now we can solve it. So when we solve this, we're going to go minus 85, and we end up with 37 minus 85, I think is like 252 maybe, equals 42x, because 85 is canceled. Now I'm going to divide by 42, and I get x is equal to 6, I believe. So solving, my statement would be Miss Crafty rented the booth for 6 days. Then we have Georgia. Georgia's making her potting soil. For every 4 buckets of peat moss, this is going to be a proportion. So I need to set up a proportion is going to be 2 fractions. So it's a fraction equaling a fraction. Make sure you're consistent on where you put your units of measure. They're all buckets, but I have peat moss and I have perlite. So what we're going to do, let's set up our equation first, see if we can manage this. 4 buckets of peat moss, so 4 of the moss with 3 of the perlite, 3 perlite. Suppose that she uses 10 peat moss, so we're going to use 10 moss is on top. How many buckets of perlite should she use? We don't know, X, perlite. So we're going to say labeling, let X equal buckets of perlite. We have the equation set up, so let's go ahead and solve it with solving proportions as cross products are equivalent. So 4x is equal to 3 times 10, and divide both sides by 4. So x equals, I can't really do anything here. Oh, I can say divide by 2 on both of these, and it'll be 5 over 2, but it won't be nice and pretty. So let's go ahead and say this is 30 divided by 4. 30 divided by 4 is 7.5. So I've solved it. I have my equation and then my statement. Georgia will need 7.5 buckets of perlite. All right, this next set, when we're looking at these are tape diagrams. You'll see this on the assessment. You'll also see them, I believe, in your PFA. So when you look at a tape diagram, it's going to ask you a little bit, this is kind of in class of what do you see, what do you wonder, what are some possible variables, values, etc. I'm going to walk through this first one. Basically, each of these boxes are being added to each other. So I could say a plus b plus a plus, like put a plus in between each one, equaling, and then this is my total. Another way of writing this, I could say is 4, because I have 1, 2, 3, 4 boxes of the exact same thing, equaling my total. From there, you can plug in some numbers and I would plug in numbers for A and B and then solve for C. For instance, I could say A is 1, B is 2, and we can find C by saying, well, 4 times 1 plus 2 equals C. So 4 times 3 would equal C. So now I know that 12 is equal to C. That's one option. You can plug in any numbers for A, B, and find C. So that now we're going to have some stories to go with the diagram that represent a group. So this first one is May had some flyers for 5 volunteers in her club. They're hanging around school. So she gave 5 of flyers to her first volunteer. Here it is. 18 flyers to her second volunteer, and then divided the remaining flyers equally. And she didn't know how many were in the stack, so there were X, X, and X amongst the next 3 volunteers. So to write an equation for this, I could say 5 plus 18 plus 1, 2, 3, 3x is equal to 50. And then we can solve it. So we could write our equation, and we can solve. This would be 23 plus 3x equals 50. Take away 23. So 3x is equal to 27, and divide by 3. X equals 9. So I solve it, and my statement would then be each of the last 3 volunteers had 9 flyers. All right, the next one, thanks to her 5 volunteers, May gave each of them the same number of stickers. So anything that says like the same number of stickers, that's where your variable comes in. In this case, it looks like she did the Y. And then she gave them each 2 more, so she gave them each 2 more. So she added 2 to it. That's where we end up with a y plus 2. Altogether, that's her total. She gave them 30 stickers. Here's your 30. Again, I have 1, 2, 3, 4, 5. So I can do 5 times the quantity y plus 2 equaling 30. Now I'm going to have you write this 2 times because we can do it 2 different ways. 5 times y plus 2. When I see problems that have the 5 up front with this is distributive property. Yes, I can always go 5y plus 10 equals 30. Take away 10. I get 5y equals 20. Divide by 5, y equals 4. Another way I could do this, if you can see it ahead of time, is that 5 is being multiplied by this quantity. So if I had just had like a 5x equals 30, I would have divided by 5 and got x alone, right? So if I can do this, this is like my variable that I'm multiplying it by. This is the part that I'm multiplying the 5 by. This is a factor. So the 5 is a factor and the y plus 2 together is a factor. I can divide by 5 since the 30 is divisible by 5, nice and pretty. And they would reduce and I would be left with that variable portion by itself. And now I have y plus 2 equals 6, and I can just take away 2 from both sides. And I'm going to also get 4. So either way, whichever is easiest for you. And y stands for the number of stickers May gave at the beginning for each. The next one distributed a group of flyers among the 5 volunteers. So again, we have 3, 4, 5. Okay, we have 5 groupings, so she let that be W. And then she remembered that she needed some to give to the teacher. So she took 2 flyers, that's minus 2, from each of the volunteers. They had a total of 40 flyers. So 1, 2, 3, 4, 5 of the exact same thing. So I could say 5 of W minus 2 is equal to 40. Now I'm going to go ahead and show you how you can multiply or divide out that 5. W minus 2 now is equal to 8. Add 2 to both sides, and I end up with W is equal to 10. Which means that W up here, the flyers that she gave amongst her 5 volunteers, she gave them each 10. The next part I want you to try on your own, aka the Toyo. Try those on your own. And this last part, I want you to actually work through as well on your own. These are going through, you're going to say, anytime you see a question mark, I want you to fill in the operations. So they're going to be add, subtract, multiply, or divide. So 48 what? Negative 8 to get negative 6. Well, 48 is divide. And then just do that for each one of those. This next part, which question cannot be answered by the equation? So I'm giving you the equation. You can write it out like this. You could write it out like x, 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 and put your little box. Do your, if that helps you. But which of these cannot? There'll be one of them that cannot. Which equation? Which question? Then the last one, I want you to go ahead and do this one just like we were doing the others, but try it on your own and answer the questions.